Hello, mathematicians, puzzlers, and other curious people. This is a follow-up post to one I did last month. Let me just show you as a reminder which one I'm talking about. Whoops, that scrolled. Okay, let's see. Where did it go? There it is. Okay, didn't scroll very far. Good. So it's the vertex formula proof video. So in this video, the idea was that we proved the vertex formula for a quadratic equation, a parabola, by using some calculus. Now, there were some possible questions about that a person might ask, and one of them was, well, there's more than one formula to do with a vertex. In particular, one option for how you can handle finding the vertex of a parabola is to put the equation in what's called the vertex form. So in this form of a quadratic formula, a quadratic function, we're told that hk is the vertex if it's written in this order. So we have a times the square of x minus h and then plus k, where h and k, also a, but that one's not as important, but I'll go ahead and jot that down over here anyway. So a is actually the same as it would be the usual way, where that quadratic function could be written as ax squared plus bx plus c. So that a, it turns out, is the same. H and k are different from b and c. And we're told, and that's kind of the whole point of this formula, that hk is the vertex. And there's more than one way to look at figuring that out, but we're going to prove that hk is the vertex using calculus. By the way, if I'm writing a little slow this time, my doctor at the clinic I go to thinks I have a little bit of carpal tunnel, so I'm wearing this thing around. We're just trying to keep it from getting any worse. So I might be writing a little slower or a little less neatly than usual as I get used to it. It's not something that's going to get really bad, we don't think, but we're just trying to keep it that way. It's a preventive kind of a thing. Okay, so please bear with me though as I get the hang of this. Okay, so we're proving that hk is the vertex of this quadratic function. And again, we're going to just skip over how we get it from standard form to vertex form. That's a topic for another video. We're just going to say, okay, we're given this form, we want to show that that would be the vertex. Well, I'm going to think about what we did last time. So last time we found that vertex by saying, okay, either it's a minimum or it's a maximum, but it's something like that. So the tangent passing through it would have a slope of 0. So the derivative at that vertex should be 0. So if I can show that, I can work backwards to get to that vertex. Okay, so what we're saying is that the derivative at h should be equal to 0. Well, we can find that out if we have a formula for that derivative. So I'm going to say, okay, we're calculating a derivative, f prime of x. Okay, a is just some real number. So that's going to be that constant factor rule. Okay, so now we've got x minus h squared. So I'm going to say, okay, we need some chain rule up in here. For the chain rule, there's more than one way people deal with remembering this. What I use is outer prime of inner times inner prime. What some people will do instead is they'll say, okay, f of g of x. So f is outer, g is inner. If we're taking the derivative of that, is going to be f prime of g of x times g prime of x. And again, that's just outer prime of inner times inner prime. Whichever way you're comfortable with using it, well, that's what we've got here. Okay, so we're taking x minus h and squaring it, and then we want to know the derivative of that. Well, the outer function I see, the thing that we would do after the other calculation, is x squared. That tells me that outer prime would be 2x. Okay, so then that inner function would be the x minus h. Well, inner prime, let's see, h is a constant, so it doesn't change. So inner prime would be x. I'm going a little fast through some of these calculus steps. If you've taken calculus, you're probably right along with me, or at least, actually, wow, copying error there. That inner prime, let's see. I'm going to, let's see. Okay, let me just fix this because I just saw a mistake I was making because I was going too fast. Remember, being a good mathematician is not about avoiding all mistakes. It has a lot to do, though, with catching them and fixing them. So let's be mathematical here. Okay, so that constant does not change, so it doesn't affect the derivative. And then as x changes by 1, well, x changes by 1. So the derivative of the x part there is just the x. Okay, so that's going to make it easy, because when we have that g prime of x, that's just going to be 1. So this will be an easier than usual formula. So now we need outer prime. So let's see, 2 thing, plugging in the inner, so 2x minus h, times inner prime times 1. So we can just leave that off. Okay, so what we've got here is a times double the difference x minus h. And then plus k, well, again, k is just a number. It's a constant, so that's not going to do anything. Okay, so the formula there would be, for the derivative of that would be 2 times a times x minus h. And we could tidy this up one step further as 2ax minus 2ah. We can use whichever of these formulas we want to for our next step. I'm actually going to use this one because when I sat down to try this before making the video, I noticed that I ended up factoring it anyway. So sometimes the completely distributed form is the better form to use. Sometimes the factored form is the better form to use. It just depends on what you're trying to do with it. There's not one right form of a lot of these things. So let's see. We're looking for where that comes out to 0. So 2 times some constant times the difference between x and h comes out to 0. Okay. Well, we know that 2a is not equal to 0 because a is, for it to be quadratic, not equal to 0, and 2 times a non-zero number will be non-zero. So now I know x minus h equals 0. Okay, well, if x minus h equals 0, they must be the same, so x must equal h. So that tells me that where x equals h is where we find that vertex. Now, what about its value, though? Because we had 2 parts in that vertex. We had 2 coordinates there. The h from right here and the k. Well, let's see what happens. So let's plug that in. So let's see, we know that f of x equals a times x minus h squared plus k. And we're plugging in h for that value of x because we're trying to evaluate it at that vertex. So we're finding the y-coordinate of that parabola when our x-coordinate is that vertex. So, let's color code. Color coding is awesome. Okay, well, h minus h is 0. So a times 0 squared plus k. Well, 0 times 0 is 0. So then we are saying a times 0 plus k. Well, a times 0 is 0. So we've got 0 plus k. Well, that's just k. So that tells me that f of h equals k. Okay, so whichever of these we're looking at, we have this. And one thing that's important about this is, like the calculus version in the other one, we didn't rely at all on the idea of averaging out two zeros. One important thing about that is it does not matter if the zeros are imaginary for these calculus methods for proving it. So now we have that proof, or at least we said a lot of things that would go into that proof. We would be a little more formal if we were writing this up for publication in a mathematical journal, but I'm just going to say, okay, we've proven it. So we've got all the information here to convince anyone who understands calculus and proof that that really is a form of a quadratic function that shows you the vertex. So now I just need to say, for the moment, calc you later.